All right, guys, today we're going to, first day of online stuff, we're going to do inverse variation. I introduced this to you the last day we were at school, which seems like about a year ago, so you probably don't remember much of it, but hopefully it looks familiar once we get going. But inverse variation. All right, inverse variation works like this. If two variables are related in an equation like that where y equals a over x, remember a is called the constant of variation. If that is true, we say y is said to vary inversely with x, and the a is a constant, which means it's a number that never changes. Way back this year, we did something called direct variation, and direct variation the equation worked like this. It worked like y equals a times x. It was a linear equation which went through the origin, and a represented slope, constant slope. A y equals ax. It was the constant variation. That's called direct. Today we're doing inverse, where it's like this. Another way to write inverse is you could do this. Think about taking the fraction out, multiplying both sides by x. You get x times y equals a. So if you don't know what a is, what the constant is, you can multiply your x and y, and that gives you your constant of variation, or your a, every time. Just multiply the x and y together. Okay, what they're going to do first is give you three examples, or some examples, to say which one is direct, which one is inverse, and which one is neither. Which means what you basically need to do is get the y isolated. So I'm going to take this part A right here. If I isolate the y, I would divide both sides by x. So I'm going to say y equals 7x, 7 over x. And if you remember from the last slide, that looks just like our inverse variation. So it would be inverse. Okay, the second one, y is already isolated. We have nothing where there's a plus sign. It's either this with division in it, or it's multiplication in it if it's direct. So this is a neither. That's a neither. No addition or subtraction. This one, if I were to isolate the y, I would get y equals 4 times x. And because that's multiplication, that is direct. That's what direct looks like. Direct looks like slope-intercept form, where the constant, and remember that's your a right there. In this first problem, that was your a on top. And the number is your constant of variation. Inverse has division in it. Direct has multiplication. You multiply the x. In inverse, you divide by the x. That's the difference. But also don't forget, you can write inverse with the multiplication as long as your constant is by itself, like x times y equals 7. Those two are the exact same thing. All right, two variables x and y vary inversely. Misspelled that one. And y equals 7 when x is 4. Write an equation that relates to x and y, then find y when x is negative 2. Okay, so it says y and x vary inversely, which means it's like this: y equals a over x. And it tells me what y is. Y is 7 when x is 4, so I'm just going to plug those in. And if I multiply across, that means a is 28. All right, so if a is 28, here's my equation. My equation would be y equals 28 over x. That's what the first part wanted me to do, right? The equation that relates them together. Now, remember, I could also write it this way: x times y equals 28. And what I can do now is it says find y when x is negative 2. So I'm going to use this one again and just put the negative 2 in for the x. Y equals 28 over negative 2, which is negative 14. So there's my equation, which it asked me for first, and here's my answer for what y was when you plug negative 2 in for x. Okay, there's another way to work this problem, this is the same kind of problem, maybe a little bit quicker. This is y varies inversely as a square of x. So instead of writing it this way, instead of writing it like I've been doing, like this is a square of x, so it's x squared this time, I'm going to go ahead and set it up like this: x squared y always equals the x squared y. It gives me one set right here, like x is 4 when y is 3. So I would say, okay, if x is 4, I'm going to do 4 squared times 3. And it's always going to equal the constant. It's going to equal the same thing. So when it says find y when x is 2, I'm just going to plug 2 in there like that, because they have to equal the same constant. They have to equal the same thing. So the left-hand side is 48. The right-hand side is 4y, which means y is 12. That's just a little bit quicker way of doing the same thing we did on the last slide. Go ahead, because they always equal the constant. If they give you this much information in a problem, you can go ahead and write it like this, like one big equation, and solve it that way. Inverse variation. Okay, and the last one. I'm going to blow this up for a little bit. It says the number of songs that can be stored on an MP3 player varies inversely as the average size of a song. Okay, it says the number of songs that can be stored varies inversely as the size. So I'm going to say, okay, number of songs, I'm going to put number, N for number, equals a constant over the number of over the average size. So I'm going to use S for size. Then it says a certain MP3 player can store 2,500 songs when the size of the songs is 4. So it means 2,500 is how many songs is the number. The average size is 4. So if I multiply that across, I'm going to get my constant is 10,000. Okay, it says write a model that gives a number. So the model is going to be this. The number is going to be the number of songs is 10,000 divided by the size. That's the model. Then it says make a table showing the number of songs that will fit on the MP3 player. So if I'm going to make the table, move this stuff up here. I'm going to put my number, my number and the size. And the first one says the number is, let's see, if the average size of a song is 2. So if it's 2, I'm plugging it all in there. That means the number of songs would be 5,000. If it's 2.5, plug that in there again for S. So we get 2,500. If the size is 3, it's going to be a weird number here, 33, really 0.33333. I'm going to stop it right there. And if it's 5, it'd be 2,000. And one thing I haven't made a big deal about inverse variation, this works, this is true a lot, unless negatives are involved. Look what happens at the end. As the end is getting smaller, the size is getting larger, which means that's why they vary inversely. They go different directions. So, varies inversely. Now, your assignment for this video is going to be on Delta Math. You need to go to the school website, mainly go to Google Classroom and see what it is. Or just go straight to Delta Math and you'll see the assignment already there for you. Find your class, you're good to go. And good luck on the assignment. Text me. Remember, I'll be available for you. Text me if you need me. I have another video tomorrow, but text me on Remind, and I can help you with any of the problems you see on Delta Math at all. So please text me. Make sure you get this assignment done today. This will be Wednesday's assignment, and the assignment on Delta Math needs to be turned in on Wednesday. All right. Miss you guys. See ya.